All right, welcome to session one for lesson 12. We're going to move on from decimals and now into fractions. In our previous decimal lessons, we were referencing and talking about fractions now and then, so it won't be totally unfamiliar, but we will start slow and go over some review, starting with this warm up on some equivalent fractions. Okay, so it asks us to use fraction tiles. We can't really do that for today, so we're just going to have to do this mathematically to make five fractions equivalent to one half. So how you do that is basically all of these examples of one half, we can increase their size, but overall they'll still equal to one half. So an equivalent fraction um, means it's equal to. Let me write that above there. Equal to. So for example, one half is equal to, let's see, 2/4. One half is equal to 3/6. One half is equal to 4/8, 5/10, and 6/12, and so on. Like you can go on and on and on and just keep doubling it. Or so basically, if we're top and bottom by 2, top and bottom by 3, top and bottom by 4, top and bottom by 5, top and bottom by 6. And um, that way everything's equivalent. So, and these would all reduce, like every single fraction here would reduce to one half. So that's why they're equivalent to one half, because they're all equal that way. All right, so there's that. So let's start with the lesson. Again, it's a short one because it's one of the first ones for this. So page 227. And for those of you that cook or bake, or will become future cooks or bakers, whether for your families, yourself, or for your work, you will run into this quite often where you have to measure things out. A lot of fractions are used for cooking and baking. But we make it easy with you've got measuring spoons and measuring cups with printed, with everything's printed on there so you can kind of see. But as you get cooking and baking more, you kind of see how fractions are used all the time. And stick of butter is a perfect example because with fractions, we talk about parts of a whole. Like, so if we talk about half a stick of butter, it's one of two parts. Or if we talk about a quarter stick of butter, that's uh, one of four parts that you took that one whole and broke it up into. So let's just jump right into this first question. Um, Emiliano needs half a stick of butter to make cornbread. He also needs a quarter stick of butter to make apple muffins. What fraction of a stick of butter does he need in all? Well, what we can do is we've got half a stick of butter and a quarter stick of butter. So we're dealing with one half plus one quarter. And we can't do that. We can't add these up as they are because the bottom number, also known as the denominator, they are not the same. So, like we did with the warm up, we can change one half into a number that has the same bottom number as the 1/4. We can change one half to 2/4 and add 1/4. And again, when we add our fractions, we add the top numbers and keep the bottom numbers. So we've got 3/4. Okay, pretty straightforward. Let's go look at the next page. All right, turn the page to page 228. Explain how you found how much butter Emiliano needs. Well, we found a common denominator for one half and 1/4. That was the first step for that. Look at Question 2. Before adding fractions, the fraction must have the same size parts of a whole. Um, you can use what you know about multiples and equivalent fractions to find a common denominator for fractions that have unlike denominators. So for part A here, use the fractions 1/2 and 1/3. Write the next four multiples of each denominator. Then circle the multiple that 2 and 3 have in common. So multiples of 2 is basically 2, 4, 6, 8, and 10. Multiples of 3 are 3, 6, 9, 12, and 15. So and we see right away that 6 is the number that's in common with them. So that's our common denominator. You're also probably thinking you can also take the denominators, the 2 and the 3, and multiply them together. That 3 times 2 equals 6. And that guarantees you a common denominator every time. What you'll run into later on is we will be able to find much smaller denominators or much smaller common factors or multiples, excuse me, that we could use instead that make our reducing a lot easier. But we'll get into that in tomorrow's lesson. All right, so part B, complete the models and equations to show equivalent fractions for 1/2 and 1/3. So what they want you to do is shade in the same amount of shapes on this one. So 3 parts of the 6, and as you can see, both of those are half of that circle. This one is broken up into thirds, so we would fill in two of these, so 2, 6, and that shows that they're the same. Use the equivalent fractions to add. So 1/2 equals 3, 6, 1/3 equals 2, 6, and that gives us a final answer of 5, 6. Pretty straightforward. And let's look at 3. What equivalent fractions could you write to add 1/2 and 2/3? Okay, so 1/2 adding 2/3. So if we want our bottom number, our denominator, to be a 6 because we have a 2 times 3 equals a 6. Okay. To change this 1/2, we've got to do times 3. That gives us 3, 6. The 2/3, we've got to multiply times 2. Oops. Did a little neater. That equals 4, 6. So then 3, 6 plus 4, 6 equals 7, 6. And 7, 6 could be our answer. Or you could turn this, since this is a improper fraction, we can change it to a mixed number. We look at our top number here and we know how many groups of 6s can we pull out of that 7. We can have 1. And how many we have left? We have 1. So these are equivalent. 7, 6 is the same as 1 and 1, 6. And throughout our lessons, I'll let you give me the answer either way because they're equivalent, they're correct. So it's just good to know how to do that. Okay, finishing up, you are going to do IXL today, K1, it's fractions review. You'll be looking at some pictures and doing some equivalent fractions and just basically get an overview and reminder of how to do fractions. You just have to go to 70% and then you'll be done. And if there's any questions, you can always ask me and we'll go over everything you need. Thanks.